The history of air power is the history of attack and defense. The struggle between the need to get to a target and the need to protect it. It's a battle the defense has been winning. Until now. Radar, radio detecting and ranging, changed everything. It was the key to the Royal Air Force winning the Battle of Britain in 1940. It came very close in 1943 to letting the Luftwaffe win the air war over Germany. The Cold War that followed was another story. The United States wanted intelligence about the Soviet Union, but there could be no massive suppression of Russian fighters. The result was the now famous U-2 spy plane, a design that was an outstanding success until one piloted by Francis Gary Powers was shot down in 1960. That reformed offense led to a redoubled effort to find an offensive solution. The same group which earlier had designed the F-104 Starfighter came up with a secret supersonic reconnaissance aircraft, the A-12, which subsequently evolved into this. The SR-71 Blackbird. This big black monster can maintain a cruising speed of 2,300 miles an hour and at a height of 95,000 feet. It holds all the current aircraft speed, altitude, and speed over distance records. For years, it was one of the tightest held secrets in the Western world. An immensely powerful, blindingly fast superplane. It was designed to be flown against the most sophisticated air defenses in the world. As proof of its capabilities, the SR-71 repeatedly overflew North Vietnamese and Chinese airspace without being successfully attacked between 1967 and 1972. The SR-71 Blackbird flies so high and so fast, it can theoretically only be brought down by the Soviet Union's monstrous Griffin SA-5 surface-to-air missile, traveling at Mach 5, and only then if it uses a nuclear warhead. As it gently bobs on subsonic air, take a close look at the world's fastest airplane. The reason it's so fast is the same reason a Formula One race car is fast. It has an incredibly high power-to-weight ratio. Weight has been kept down by building the SR-71 almost entirely out of titanium, one of the lightest metals on Earth. The strength comes from its two unique Pratt & Whitney engines, each rated at 35,000 pounds of thrust, enough to drive the world's largest ocean tankers. You can see one reason they're unique in the mouth of each engine. The two cone-like objects, or spikes, have a crucial role. Up to about 1,600 miles an hour, each engine acts as a normal turbojet. Then, as the speed increases, they become ramjets, with their afterburner providing practically all the thrust. To do this, the spike is automatically moved forward and back as the speed changes, so the shock wave just hits the leading edge of the inlet, maximizing the amount of ram pressure. The whole effect is so mean-looking, it's sometimes hard to really see the shape of the SR-71. Note that it's made up of a few long straight lines and a great many curves. See how the sides of the body are flared out into broad chines, and the same treatment is applied to the outer edges of the engine nacelles. Note that the wing is basically a large delta, and that the engines are partially shielded by those cones. Note, too, that the two vertical fins lean inward, and finally, note again that the whole outer skin is painted black. All of these elements came as the result of testing its predecessor, the A-12, on a special radar test site and making changes accordingly. The location of the engines, for example, was designed to make the aircraft as small as possible from the side and from the front, the direction of the potential acquisition radar. The chine and the angled wing and fins eliminated vertical surfaces, so radar would be reflected at an oblique angle. And the aircraft was painted with radar-absorbent material, or RAM, to further weaken the return.
Terry approaching Mach 3. Roger that. Okay, John, we're stabilizing at Mach 3. I'm showing 81,400 altitude. And checks. And indicating Mach 3.0 at this time. Level off checks. Inlet set. Inlet's check good. Fuel check. Yeah, it looks like we're about 3,000 low in the fuel. Roger that. Okay, this will be a problem. Plan no lower than 2,000 pounds. Let me take a look at the flight plan. I'll be right back with you. Okay. Yeah, we definitely have a problem here, Terry. If we don't improve our situation, we may be in abort. Okay, I'll start see what I can do from this end. Let's take another close look at it as we approach the sensitive area. You bet. Now, about 1 minute out of the sensitive area at this time. Checklist is complete. And fuel trend is positive. Still showing us 2,500 pounds low. Not enough to go. Roger that. I'm going to aft transfer to get our CG to a more efficient level. Roger, monitoring. Terry, about 30 seconds to the next turn point. Roger that. Stand by for the hack. Ready, ready, hack. 15 seconds to go. Got it. Fuel is very close. Check it out the decision point. That's at rollout. Checks. Stand by for the turn. Ready, ready. Index. Turn. Back ankles look good. Attitudes cross check. Looks good. Gentlemen, adjust speed slightly to give you a smoother platform. Roger. Rolling out. At the decision point, rear cockpit, go. Front cockpit's good. Fuel holding at 2,000 low. That's been acceptable. Okay, that's right on the ragged edge. We cannot accept any fuel degradation. Roger. As long as the temps, outside air temperature holds, will be good. Yeah, I think it's going to work. Stand by for sensor activation. Sensor's coming on now.
Both 5 for flight, roll out heading 010.
Once passed, the two ramjet engines with their brilliant exhaust and titanium and steel nozzles would present an enormous radar and infrared target. But from the rear, an SR-71 is virtually impossible to catch.